Hello, this is going to be a lecture out of the supplemental text that we have. It is Pharmaceutical Calculations for Pharmacy Technicians. In your Pharmacy Calculations module, this should be the last text in the reading tile for you. So let's get started. Chapter 1, Fundamentals of Math. So our chapter objectives here say that by the end of this chapter, you should be able to convert Arabic numbers into Roman numerals and Roman numerals into Arabic numbers. You'll be able to perform basic computations, including addition, subtraction, multiplication, and division using Roman numerals and Arabic numbers. You'll also be able to list the basic unit of weight, volume, and length, and demonstrate how to write abbreviations and use notation rules for metric, apothecary, and household units. You'll also be able to calculate the equivalent measurements within the metric system, compare apothecary and household equivalents. You'll be able to write measurements using apothecary symbols and interpret symbols from different systems that are used in pharmacy. You'll also be able to convert equivalent household measurements. And you'll be able to convert between household and metric measurements and calculate measurements in milliequivalents and units. So we're going to start first with Unit 1 is going to focus on number systems. So the most common numbers used throughout the world today are Arabic. These are the numbers that we are used to seeing, and I know the screen is kind of small, but when we see numbers like 1, 2, 3, 4, 5, right, these are Arabic numbers. So pharmacy technicians must be able to interpret Roman numerals as well as the Arabic numerals. So with your Arabic numbers, by combining the digits 0 through 9, any number can be represented. Your Arabic numbers can be written as whole numbers, as fractions such as 1/2, 1/3, or 4/5, and even as decimals 0.5, 0.6, 1.7. Your Roman numerals. So these are letters which represent numerals. So the building blocks of the Roman numeral system include the letters. That is a capital I. Sometimes your doctors might use a lowercase letter for these, but typically with Roman numerals, they will be capitalized. We have the letter V, the letter X, the letter L, the letter C, the letter D, and the letter M. Each of those letters represents something. My apologies. So the capital I represents the Arabic number 1. The capital V represents the Arabic number 5. A capital X represents the Arabic number 10. An L represents the Arabic number 50, 50. A capital C represents 100. In case you've ever heard a $100 bill referred to as a C note, that is why, because the Roman numeral C represents 100, and dollars are technically considered notes, hence C note. The capital letter D represents the Arabic number 500, and in Roman numerals, the capital letter M represents the Arabic number 1000. So these Roman numerals, as I mentioned, can be written as either uppercase or lowercase letters. Sometimes a horizontal line is written above lowercase letters. So for example, the number 4 can be written as either a lowercase I and a lowercase v or capital IV. And the last example is avoided in order to not confuse it with the abbreviation for intravenous. So your doctors may resort to writing that one in lowercase just to prevent that confusion. When the letter I is written with a horizontal line above it, the dot of the I would appear above the line, much like this. That would represent a 1. Or I could do it like this. That would represent 2. And again, I apologize. I know it's a little small on that particular screen. All right, so table 1-1 shows you the Roman numeral symbols alongside the Arabic equivalent. So our SIG code SS is technically a Roman numeral. It is the Roman numeral for 1/2. A capital or lowercase I represents the Arabic equivalent 1. V is the equivalent of the Arabic number 5. An X is the Arabic number 10. An L is the Arabic number 50. C, again, C note, C is equivalent to the Arabic number 100. D is equivalent to the Arabic number 500, and M is equivalent to the Arabic number 1000. So when we are reading our Roman numerals, when a letter appears 2 or 3 times in a row, the letter's value is counted for each time it appears, or we're going to add the letter's value. Roman numeral letters will never be repeated more than 3 times in a row. So that is why the number 4 is expressed with an IV instead of 4 I's. If a lower valued letter follows a larger valued letter, the letter's value should be added. If a lower valued letter is placed before a higher valued letter, the lower valued letter is subtracted from the higher value letter. So let's look at what that means. So if I have two capital I's together, right? These are the same. So it literally becomes like 1 plus 1. So this equals 2, right? If we did it with the X's, right? Because again, we can't repeat this Roman numeral character more than 3 times in a row. This literally becomes 10 plus 10 plus 10. That is 30. Some people like to put a line like so to help keep track of how to add these values together, and that is perfectly fine. Okay, so again, that capital I represents our Arabic number 1. And so when a character in Roman numerals of the same value or lesser value follows that first character, we're just going to continue adding those. So this, like I showed before, is literally 1 plus 1, and it becomes 2. Then we have 1 plus 1 plus 1 gives us 3. And as it was just stated, we cannot repeat our Roman numeral characters more than 3 times in a row. So when we get to this one, it changes. And now we have a small Roman numeral in front of a larger valued Roman numeral. So this, I literally have a 1, right? If I did a line, and a 5. So when this happens, that Roman numeral of smaller value is going to be subtracted from the Roman numeral of larger value. So this literally becomes, there's your large value, there's your small value, 5 minus 1, and that is how we get to the 4. So here's another example. Remember what the X represented? So we could potentially draw a line between our numbers here. And this side is going to be 10 because that is what the X represents. And then here on this side, I have a small number in front of a large number. So remember, our capital I is a 1. So we need to take 1 away from 10. That leaves us 9. This is not producing a negative number. We're just taking 1 away from 10. And then we're going to add the 10 plus the 9 to determine that that is the Roman numeral 19. Let's look at a couple of more examples. Okay, so I have some examples here. We're going to start up here at the top. So again, if you're one of the people that needs to maybe separate your Roman numerals, we could separate it like so. Remember, our D is 500. Your C's are 100. And here I have 2 of them, so that's 100 plus 100. And what is the L? Hopefully you remembered that it is 50. Now, all of these numbers, right, they start with a big number and they sequentially decrease. So I don't have to do any subtraction with these. I can just add them together. 500 plus 100 is 600, plus 100 is 700, plus 50 is 750. Again, if you need to separate your characters, that is fine. Maybe we'll separate them like that. And so M, remember, is 1,000. C is 100. And M is 1,000. So we know we're going to have to subtract 100 from that 1,000 there. Here I have an L, which we just said was 50. I've got 2 X's. That's 10 plus 10. And then we have a 5. So now we can proceed to do our math. We do have a subtraction in here, right here. So 100 from 1,000 leaves us with 900, right? So I'm just going to write that in there. So now I've got 1,000 plus 900, 1,900, plus 50. So now I got 1,950, plus 10 plus 10. So 1,950, 1,960, 1,970, and a 5. So this would be 1975. Next number, again, we may want to divide these up a little bit. So remember, my C is 100. My D is 500. So small number in front of a big number, we know we're going to have to take the 100 from the 500. It's going to leave me with 400. So I'm just going to jump that in there by the C. And then same thing's happening here on this side. We have an X, which is 10, followed by the L, which is 50. So I know I'm going to have to take 10 from that 50. That means this is 40. So now I can take my 400 and add it to my 40. That one is 440. And then our last one here, again, if you like to divide your characters, that is probably how I would go on this one. And so we have 3 C's. Each C is 100. Those together come to 300. Here I have a 10 in front of a 100. So I'm going to have to subtract the 10 from the 100. This leaves me with 90. And same thing here. I have a 1 followed by a 5. So I need to subtract the 1 from the 5. And so this leaves me with 4. Now I can do my addition. 300 plus 90 is 390. Plus 4 is 394. All right, let's get back to the PowerPoint. All right, so our next slide, they give us a few math problems here. So they give you two lowercase i's, and they're showing you the breakdown of that. Remember, each I represents the Arabic number 1. So two i's together is the same as saying 1 plus 1, and so they equal 2. Next, we have an xii. X, remember, is 10. Your i's are 1, so x plus 1 is 11, plus 1 is 12. Next, we have 3 x's. That is the same as saying 10 plus 10 plus 10, and 10 plus 10 is 20, plus 10 is 30. Next, we have the IV, which is 5. The V represents 5. The I represents the 1. So remember, we have to take 1 from the 5. That left us with 4. Next, we have an IX. So remember, the X is 10. That I represents 1. Because the I is in front of the X, we need to take 1 away from that X. That leaves us with 9. And then the last example they give us there is an XL. That X represents 10. The L represents 50. Because the X is in front, it needs to be subtracted from the 50. 50 minus 10 gives us 40. So there is no Roman numeral for 0. If you are looking for one, it just doesn't exist. Roman numerals are used less frequency in dosage calculations. In pharmacy practice, Roman numerals may be used to denote quantities on prescriptions. That's where we most commonly encounter Roman numerals in pharmacy. I can also let you know that sometimes when we're talking about eye drops, ear drops, for some reason, when we talk about drops, the doctors want to default back to Roman numerals for drops. So usually if we're talking in terms of drops, you'll see Roman numerals, and you'll see Roman numerals listed for patient quantities. So here they give us, Here they give us to convert Roman numerals to Arabic numbers, convert the Roman symbols to Arabic symbols or numbers before adding or subtracting. So they give you the example here of XV. So remember, X represents 10, V represents 5. V is smaller than X, so we can simply add these two values together. 10 plus 5 gives us the 15. The next example we have is XXVIII. Remember, X represents 10, so we have 10 plus 10. V represents 5, so we have 10 plus 10 plus 5. I's represent 1, so that's 1 plus 1 plus 1. And 10 plus 10 is 20, plus 5 is 25, plus 1 is 26, plus 1 is 27, plus 1 is 28. And lastly, XIX. X is 10, I is 1, and X is 10. So we have a 10, and then that second X has a 1 in front of it, so we need to subtract 1 from that 10. And so it becomes 10 plus 9, which leaves us with 19. So here is another table expressing the converting between the Roman system and the Arabic system. This one is showing you the Roman numeral in both capital and lowercase letters on the left, and the Arabic equivalent listed along the right. And that is a continuation of the same table. So we're given a knowledge check here. How is the Arabic number 16 represented in Roman numerals? Give you just a moment to think about that. All right, so how are we going to go about writing this Roman numeral 16? Well, how about an X, right? That's 10. What's going to come next? How about a V for 5? Now I've got 15 written up there. and then I need an I, right? 10 plus 5 plus 1 is going to give me my 16. And so there's your answer. You could have written it in capital letters like I did, or you could have written it in lowercase letters. All right, just a moment. We'll move on into the metric system. All right, continuing on into Unit 3, the metric system. So the metric system was developed in France in the 18th century for scientific studies and calculations. It is the official system of weight and measures used for weighing and calculating pharmaceutical preparations. This system is sometimes referred to as the International System of Units. It was derived from the French Système Internationale, or SI. Pharmacy technicians need to be concerned primarily with the divisions of weight, volume, and linear measurement. So the units of measure in the metric system, we have 3 basic units of measurement in this system. The first is for weight, and that is the gram. This is abbreviated as the letter G, lowercase, or GM. The basic unit of volume is the liter. This is abbreviated with a lower or uppercase L. And the basic unit of length is the meter, abbreviated as the lowercase letter M. So under gram, we have some other gram measurements that are common in pharmacy, such as the milligram, the microgram, and if you're doing some bulk work, you might utilize the kilogram. With volume in pharmacy, we are most commonly going to use the milliliter and cubic centimeter, or cc, which is the amount of space that 1 milliliter consumes or takes up. So cc's and milliliters are interchangeable. I would like to also add microliter to that list for the volume measurements. It's more common for your pediatric formulations, but there may be some times where you need to measure in microliters. And then for length, our common units of measure are going to be the meter, which is further divided then into the centimeter or millimeter for the purposes of pharmacy. So we have some terminology and abbreviations with regards to the metric system. The metric system is a decimal system based on multiples of 10 and fractions of 10. So it uses prefixes with all measures, which indicate the size of the unit being measured in multiples of 10. And so figure 1-2 gives you metric system prefixes and their decimal and fractional equivalents. So kilo is 1,000 times the base unit. Hecto is 100 times the base unit. And deca is 10 times the base unit. We go the other direction, we have deci, which is behind the decimal place. This is 1/10 of the base unit. And centi, which is 100th of the base unit. So here's another way to look at those prefixes. Again, kilo is 1,000. So they're giving you an example here of 1,000 meters is equal to 1 kilometer. Hecto, we have 100 meters equal to 1 hectometer. 10 meters is equivalent to 1 decameter. 0.1 meters is equivalent to 1 decimeter. 0.01 meters is equivalent to 1 centimeter. 0.001 meters is equivalent to 1 millimeter, and 0.0000001 meters is equivalent to 1 micrometer. Notice for micro, we have that sort of, it's like a U with a line hanging down long on the front side of the U. That is a symbol that represents micro. And then, of course, we have the M behind it because we're talking about in terms of meters. Sometimes you might see this with liters as the microliters that I was mentioning earlier. So some other common metric abbreviations include the nanogram or NG. We have our microgram, which instead of the backward U, sometimes we'll use the MC. Milligram, the gram, the kilogram, the milliliter, the deciliter, the liter, and the kiloliter. So metric notations. The metric system uses decimals to express units of weight, volume, and length. Temperature, speed, force, and other properties of the physical universe can be measured from these units. So we have some rules for metric notation. Do not guess about the true meaning. Anytime you're unsure, get clarification, look it up. But just do not guess. The abbreviation, this is again some of our rules. The abbreviation always follows the amount. So we should never have the abbreviation in front of the numerical value. Decimals are used to designate fractional metric units. And use a leading zero to emphasize the decimal point for fractional metric units of less than 1. And remember, we need to omit any unnecessary trailing zeros behind a decimal point. And we want to write the suffix before the basic unit of measure. So if we're talking about a kilometer, it's km and not mk. So exponents and scientific notations. An exponent is a way of expressing a number that is multiplied by itself. Scientific notation is a shorthand method for expressing large numbers that are a product of a number between 1 and 10 and or are a power of 10. Which then brings us to our apothecary system, Unit 4. The apothecary system is an old system of measurement that has been widely replaced by the metric system. However, we have certain medications such as aspirin, quinine, nitroglycerin. There are some electrolytes and various other, I think codeine is still measured in apothecary units in some instances, which is why we as pharmacy technicians these days have to be familiar with these different types of systems. So some medications such as nitroglycerin, which is pictured here on this label, still use the apothecary systems of measurement. You're seeing there inside the circle on the labeling is just notating that these are sublingual tablets, which means that they need to be dissolved underneath the tongue. However, if you look right above that, it says RX only. And directly above that in blue, or like a soft powder blue, it tells you that this nitroglycerin tablet contains 0.4 milligrams. And in parentheses, that 1/150 grains is an apothecary measurement. So the basic unit of weight in the apothecary system is the grain. The Roman numerals, uppercase letters I, V, and X are the basic symbols of this system that pharmacy technicians use in dosage calculations. So writing apothecary values. The symbol or abbreviation, just like with the metric system, is going to follow the quantity. So they give us an example here. 6 grains is written as GR, and then they give you the number 6 in Roman numerals, VI. Fractions are only used when necessary, and Roman numerals are used for 1 to 10, 20, and 30. But Arabic numbers are used for most of the other quantities, unless, again, we're talking about quantities. I've seen doctors use the letter C to express a quantity of 100 as well. So here we have another knowledge check. How will you write 5 grains using the apothecary system? Give you a minute to figure that out. And hopefully you came up with a lowercase gr and the letter V for 5. So gr space V is how we would write that one. I know it's a little hard in this small box on the screen, but that is what I have on the screen. Same thing. I mean on the board. So let's look at apothecary system units of measure. So when we talk about solid weight, we are going to be looking at things such as grains to drams, drams to ounce, or ounces to pounds. So for solid weight, 60 grains is equivalent to 1 dram, and 8 drams is equivalent to 1 ounce. 12 ounces equivalent to 1 pound. And for liquid volumes, we have 60 minims equal to 1 fluid dram, and 8 fluid drams equal to 1 fluid ounce. Table 1-7, apothecary system abbreviations. All right, so our minim, which is a way to measure volumes in the apothecary system, is abbreviated MIN, and it has a symbol there that looks much like the Scorpio symbol for astrology. Next, we have the dram, which is abbreviated as a lowercase dr, and its symbol looks much like a big 3. Next, we have the ounce, which is abbreviated OZ. Its symbol looks like a very particular style of 3 with maybe a little 7 sitting on top of that 3. The grain is abbreviated lowercase gr. It does not have a symbol, and the pound is abbreviated LB, and it also does not have a symbol. So let's take a look now at our household system. So the household system of measurement is still commonly used today. This is what most people are going to do at home unless you tell them otherwise. Pharmacy technicians should be familiar with it so that they can explain take-home prescriptions to patients. Because as you're going to learn, these household measurements don't quite add up to the metric systems of measurements. And so we could ever so slightly over or underdose our patients because of that. This system uses Arabic numerals, numbers, and common fractions. So you're not going to see too many Roman numerals with your household system of measurement. So table 1-8 has household abbreviations such as drop being abbreviated as GTT, and it also tells you some equivalents there on the far right hand side of this table. 60 drops is equivalent to 1 teaspoon. They give you a teaspoon, which is abbreviated as a lowercase t or TSP, and it lets you know that 6 teaspoons is equivalent to 1 fluid ounce. 1 tablespoon, or a tablespoon, I'm sorry, is abbreviated with a capital T or TBSP, and 1 tablespoon is equivalent to 3 teaspoons. 1 fluid ounce is abbreviated FL space OZ. So 2 tablespoons equals 1 fluid ounce. When it comes to an ounce weight, that is abbreviated just OZ, and 1 pound contains 16 ounces. A cup is abbreviated with a capital or lowercase c, although it is one of the things that we don't abbreviate. So cup is a lot of times spelled out in pharmacy. And 1 cup is equivalent to 8 ounces. Next, we have a pint that is abbreviated PT. 1 pint equals 2 cups. We have a quart, abbreviated QT. 1 quart is equivalent to 4 cups or 2 pints. And lastly, we have a gallon, abbreviated GAL, and we have 4 quarts, equivalent to 1 gallon. Please, I cannot express enough. Do not, as you're trying to do the math for these conversions, do not use Google or ChatGPT. The reason being, pharmacy rounds a lot of these measurements. For example, 1 teaspoon in pharmacy is 5 milliliters. A true teaspoon measurement is something like 4.67 milliliters. So it's actually just shy of 5 milliliters. So if you're using Google or ChatGPT it's okay to use them to see how to work your problem, but if you're using the actual numbers, Google or ChatGPT is going to try to give you true measurements, and your answers will be wrong each and every time because pharmacy rounds these numbers. So we're given a knowledge check here. We're being asked how many ounces is a measure of 4 cups equivalent to in the household system. So let's look at how we would figure that out. Okay, so we were being asked how many fluid ounces were in the 4 cups. Well, in order to address this, first we're going to start with what we have, which was 4 cups, right? And in order to even be able to begin trying to calculate this answer, you have to know how many fluid ounces are in 1 cup. That is why those common measurement conversions to know are so important, because you're not going to be able to do these calculations if you don't know those things. So I can set up an equation such as this. 4 cups, we're going to multiply it times the number of fluid ounces in 1 cup. Now, when I have a whole number, it is understood to be over the number 1. So I really have 2 fractions here that are just being multiplied together. Also notice my cups and my cup are offset because I can lose like units if they're diagonal like that, right? And when we multiply 1 times 1 for our denominator or bottom number on our fraction, we already know it's going to give us an answer over 1. And what did I just say about numbers that were over 1? They are understood to be the whole number. So I don't even have to worry about this bottom section. Really just need to do 4 times 8. Which is 32 fluid ounces. I just wrote ounces there. So let's get back to our PowerPoint and see if we are correct. All right, so let's see how we did. And our answer came out correct. 32 ounces contained in those 4 cups. All right, so moving on into mill equivalents and units. All right, so mill equivalents and units. Units, milliunits, international units, and mill equivalents are also used to measure certain medicines. The unit is a standardized amount required to provide a desired effect. It is used to measure insulin, heparin, and penicillin. The milliunit is 1,000th of a unit. And the international unit is a unit of potency that is used to calculate vitamins and chemicals. The mill equivalent is 1,000th of an equivalent. Sorry. The mill equivalent, or MEQ, is 1,000th of an equivalent weight of a chemical substance. It is used to describe the concentration of serum electrolytes such as sodium, potassium, and calcium. So we are given a critical thinking here that I don't want to address because that is an assignment. So that is the conclusion of Chapter 1 from the Pharmaceutical Calculations for Pharmacy Technicians. I'm so sorry, I'm getting muddled up here. So I hope this has helped you out, and we'll see you again in the next video.